Welcome to the Explainer. Today, we're diving deep into Java's graphical user interfaces. We're going to build the ultimate toolkit you'll need to ace your exams on AWT and Swing. Let's get right into it.
Okay, so if you're hitting NPTEL's Week 9, you know exactly what we're up against. Building GUIs from the ground up, right? It's all about taking these little pieces, these components, and putting them together into something that actually works and, doesn't look completely crazy. So let's break down the essential toolkit you'll need.
So here's our game plan. First, we'll cover the AWT core components. Think of them as the bricks. Then, we'll look at how to arrange them with layouts. That's our blueprint. After that, we'll get into the fun part, making it all interactive with events. Then, a quick look at the modern toolkit, Swing. And finally, we'll wrap up with a key exam review to make sure you're set.
All right, first up, the Abstract Window Toolkit, or AWT as you'll always see it. This is the granddaddy of Java GUIs. It's the original foundation, and you really got to understand it. Think of these components as your fundamental building blocks, kind of like Legos for your applications.
Okay, exam focus time. Everything, and I mean everything, you build in AWT has to live inside a container. The big one is the frame. That's your main application window, the thing with the title bar and all that. Now, inside that frame, you can use a panel. A panel is basically a container within a container, perfect for organizing groups of buttons or text fields. And then there's the dialog. That's just your simple pop-up window for getting some quick input from the user.
Now, these are the bread and butter. You are absolutely going to see these components on your exam. You need to know what they are, for sure. But the really crucial part, you have to know which events they generate. A button click? That fires an action event. Ticking a checkbox or picking from a choice dropdown? That's an item event. Knowing that connection is key. So, now that we have these pieces, how do we actually, put them on the screen?
Okay, this right here is the magic recipe. You need to burn this pattern into your brain. 1, create the container, our frame. 2, create the component, our button. 3, use the add method to stick the button inside the frame. And 4, the step everyone forgets. Make it visible. Now, you'll see that set layout null line in there. We're about to get to why that's so important. Because without a layout manager, how do you control where everything goes? Let's find out.
Right. So just tossing components into a frame isn't going to cut it. You need a plan, you need to arrange them. And that, my friends, is where layout managers come in. This is a huge topic for the exam, so pay close attention. These are the tools that automatically figure out the position and size of all your components for you.
So the first one is flow layout. It's the simplest of the bunch, and it's actually the default layout for panels. It works just like typing words on a page. It places components one after another, left to right. When it hits the edge, whoop, it just wraps down to the next line. Super easy, super straightforward, but you don't get a ton of control.
Now, if you need a bit more structure, you've got border layout. This is a really interesting one. It carves up your container into 5 distinct areas: north, south, east, west, and center. You literally tell Java, hey, put this button in the north region. Super organized. And here's a pro tip for the exam. The center region is special. It automatically grabs all the leftover space. This makes it absolutely perfect for the main content area of your application.
And then we have grid layout. If you need a perfect grid of equally sized things, this is your guy. Think of a calculator keypad. That's the classic example. You just tell it how many rows and columns you want, say 3 by 3. Then, every single component you add gets squeezed into a cell of the exact same size, no exceptions. It's rigid, but it's perfect for that kind of uniform layout.
Okay, so we've got our components and we've arranged them nicely. But right now, they don't do anything. A pretty but useless UI isn't going to get you marks. The absolute core of GUI programming is handling events. We need to make things happen when the user actually does something, clicks a button, types in a box, whatever. This is how we bring it to life.
All right, you have to understand this for the exam. It's called the delegation event model. And it sounds complicated, but it's not. Think of it like this. You have a button, right? That's the source. When someone clicks it, the button basically yells, hey, something just happened to me, and it creates a little package of information called an event object. But the button itself doesn't know what to do, so it delegates that job to a listener. Your code, the listener, is just sitting there, waiting to hear that yell, and when it does, it springs into action. So let's look at the 4 steps you have to nail every single time. 1, a source, like a button, creates an event. 2, an event object is made.
3, you write a listener to handle it. And 4, this is the one everyone forgets on the exam, seriously, you have to register that listener with the source. You have to tell the button, hey button, when you get clicked, tell this specific listener about it. If you forget that add action listener step, your code will just sit there and do nothing.
Okay, screenshot this. Memorize this. This table is pure gold for your exam. It's all about matching. You see a button, you should immediately think action event, action listener, and action performed method. You see a checkbox, your brain should go straight to item event, item listener, item state changed method. It's a matching game, and you have to know these pairs cold.
Let's look at the code. This is the pattern. First, look at the top line. Implements action listener. Your class has to promise that it knows how to handle these actions. Second, inside your setup code, you have that critical registration step, mybutton.addActionListener this. That connects the button to your code. And third, you actually write the code for what happens inside the action performed method. That's where the magic happens.
Okay, so we've got AWT down. But now let's talk about its successor, the modern upgrade, Swing. You can think of AWT as the old, solid foundation of a house. It works, but it's a bit dated. Swing is like the brand new, modern renovation built right on top of that foundation with all the cool new features.
This is a classic exam question, so listen up. AWT versus Swing, heavyweight versus lightweight. What does that even mean? Well, AWT components are called heavyweight because they rely on your computer's operating system to draw them. So a button in your Java app is actually a real Windows button or a real Mac button. The problem? They can look and act a little different on each system. Swing components are lightweight. They are 100% pure Java. Java draws them itself, pixel by pixel. And the huge win here? Your application looks and feels exactly the same everywhere. Total consistency.
The best part? Moving from AWT to Swing is super easy. Honestly, for the most part, you just stick a J in front of the class name. Frame becomes JFrame. Button becomes JButton. Panel becomes JPanel. See the pattern? All the core ideas we just learned, containers, layouts, event listeners, they all still apply. It's a really smooth upgrade.
So why bother with Swing? Because you get a whole new toy box of awesome components. AWT is pretty basic, but Swing gives you powerful stuff like JTree, JTable, and JProgressBar. You can build much more sophisticated, modern-looking apps, just like that calculator you see in the lectures. It's a real game changer. All right, home stretch. Let's do a quick rapid-fire review of the absolute must-know stuff for the test. Think of this as your last-minute checklist before you walk in.
You're going to see these terms everywhere. Just drill them in. Component is the base for everything. A container holds other components. You use add to put stuff in a container. You use setLayout to tell it how to arrange everything. And for the love of all that is holy, don't forget visible true at the end, or you won't see a thing.
Okay, the 5 big listeners. You need to know them. Action listener for clicks, mouse listener for when the mouse is pressed or released, mouse motion listener for dragging and moving, key listener for typing, and window listener for, well, for window events like closing. If a question asks about the user dragging something, you should instantly know. That's a job for mouse motion listener. And remember why we have this whole delegation event model. It's not just to make our lives harder, I promise. The whole point is to keep things clean. It separates your user interface code, all the buttons and labels, from your application logic, the code that actually does the real work. It's just good, organized programming. And there you have it, your crash course on AWT and Swing. So as you finish studying, leave yourself with this last question. Really think about it. If you can answer this one confidently, explaining why you'd choose one over the other, you've pretty much nailed the core concepts. Good luck on your exams, you've got this.